This video also goes with 15.1 from the Musser book, and this talks about the collinearity test. So if you remember the definition of collinear, collinear means that all the points lie on the same line. So we need a way to decide if the points will in fact lie on a straight line. So right now I have 3 points on GeoGebra, and it would be very easy to prove using the software that they lie on a straight line, because if I just made the line going through the 2 farthest points, I would be able to see that point B was in fact on the line. But what if you don't have the visual in front of you and you need to prove it another way? And that's where we use the distance formula, which is what our previous video was about. So the question is, given the 3 points, these are the same 3 points I just had on GeoGebra, the question is, are these points collinear? So here's what I want to do. I want to figure out the distance between points A and points B. Well, the distance formula is the square root of the change in the 2x values squared plus the change in the 2y values squared. So let's just plug in what we have. We want to take the square root of, if we do point B and then point A, we're going to do 5 minus 1 squared plus 4 minus 1 squared. And that's going to equal the square root of 4 squared plus 3 squared, which is going to be the square root of 16 plus 9, which is the square root of 25. And so I get a distance of 5. Now we're going to do the same thing, except we're going to do it for points B and C. So the distance should be the difference between the 2x values, 13 minus 5 squared plus 10 minus 4 squared. So the distance is the square root of 13 minus 5, which is 8 squared, plus 10 minus 4, which is 6 squared. So that'll be the square root of 64 plus 36, which is the square root of 100, and so the distance will be 10. And so now I need to see if, so these are the 2 short pieces. Now I need to see, so this was our distance of AB, and this was our distance of BC. Now, according to the collinearity rule, AB plus BC is supposed to be AC. So that means that 5 plus 10 is supposed to give us 15. So let's see if we do in fact get 15 for the distance between A and C. So let's do this one more time. The distance should be the square root of 13 minus 1 squared plus 10 minus 1 squared. The square root of 12 squared plus 9 squared, which is the square root of 144 plus 81, which is the square root of 225, and the square root of 225 does happen to be 15, and so this would be our AC. So we just showed that these points are collinear because their short distances would equal the long distance.